This is the Lemon Grove Middle School in San Diego, California.
Today we're going to be doing an activity from a unit called Ruins of Montrec. Can anyone tell me what this is a picture of? Hey, German?
Blueprint?
Pam Hardaway teaches 7th grade mathematics.
What is a blueprint used for?
Sometimes blueprints are made for like building different things so you can see what you should be doing or something like that.
Okay, good. So what we're going to be interested in for using a blueprint is what the foundation or the base of the building looks like, and then what does the outside of the building look like. We're not really interested in, like, if you look at this, you can see the inside rooms. They tell you the dimensions of each room. We're not going to be really concerned with that. We're going to be concerned more with what does the front look like? What does the outside or the outside outline look like? Okay? In the investigations we're going to be doing in this unit, you'll be hearing the name Emily Hawkins over and over again. She's a famous explorer who goes around to ancient cities and looks at the ruins. And then she tries to reconstruct what the civilization looked like by building buildings from the ruins. So she has the system for doing that. What she uses is little cubes and what's called a building map. And what you guys are going to do right now is construct your own building map. A building map is kind of like the ground that you need to construct your building on. Today's lesson is from a unit called Ruins of Montrec, which is a geometry unit. Students are reconstructing buildings using blueprints that are given. And then what they do is look at the buildings from all different viewpoints, the right, left, front, and back, and describe what they see in the relationships between all 4 viewpoints. On your building map, you need to label the front, label the back, the right, and then the left. So what we're going to do with this mat is you're going to construct the building, first starting with the foundation, and then build up, and then you're going to look at it from you're going to use your mat to turn it to look at it from the different sides. Okay, and then you'll be drawing what those sides look like. On your tables, there should be copies of problem 1.1.
Today's problem asks students to construct a model of a building using cubes on their worksheets. They are given information about the size and shape of the building's foundation, as well as the number of cubes high. Placing the model on their building mat, students are first asked to observe each side, draw its shape, and then answer the following questions. Compare the 4 views. What relationship do you see among them? How are they alike or different? If you and a partner are on opposite sides of the model, how do your views compare? If your partner draws the back view, can you draw the front view? Why or why not?
One of the advantages of letting the kids actually use the blocks to reconstruct things and using manipulatives in class is that it helps those students who are tactile learners that actually have to do it. Whereas if you just give them a picture, they're not going to understand. They need to actually move it, feel it, turn it around, flip it upside down, and actually do it, and it helps them learn a lot better.
You just put 3 blocks here and then 2 more right there, and it's laying right here in the middle. Amber. Yeah. Not working. Okay, like this. Okay, bring that blue one right there. Take that blue one off and put it right there. And then take another block and put it right there. Okay. Thank you. And then right here it tells you like put like 1 to the front, then 1 to your left, and then like 3 in the back, and then like 1 right there, and then another 1 right there. And then now all we have to do is sketch it on here, like draw it. See how you see it in the front?
The same thing. So like 3 of these little blocks.
See how you see it like in the front, like that. Just sketch that right here.
Okay.
Yeah, just look at it from like that, and see what you see in the front, and then sketch that.
Can we draw these, the ones that are up?
Yeah.
How?
You just stack it up.
Okay, so like this, like 1 more up here?
Okay.
Make sure when you draw your viewpoints, you let me know from what perspective is that. Is that the front, the back, the right, or the left? Okay, make sure you label it.
How do I do it? Go like that, right? You have to turn it like that, like that, like that.
One of the things I love about geometry is that it's very spatial, and some students are much more spatial than others. Right now, they're doing three-dimensional figures that they're transferring to a two-dimensional drawing. And later on, what it's leading up to is going from a three-dimensional model to actually they'll be doing three-dimensional drawings.
One more. And then, yeah, that's how you're supposed to do it. That's what the front is.
So what you have to do now to figure out your drawings is you get down to eye level like this. So crouch down and look at eye level from the front, and then tell me, what do you see? Like that. What shape? An L, right. So that's what you're supposed to draw on the grid paper. Now when you need to do the back, you just take your building mat, switch it around so that the back is facing you. And now do the same thing. What do you see? A backwards L, right. So a lot of times when students are having difficulties, I think a lot of it has to do with they're not sure what the question is asking them. Like Josh today, when he was asking me, and I said, okay, crouch down, and what do you see? And he said, oh, I see this. And they think, oh, that's the answer? That was too simple. I thought they were asking me this bigger question, but actually they didn't understand if their answer was right or not, or if that's what the question was asking them to do.
Alright, so like right here, all we have to do is just like draw this building.
First, what do you have to do before you draw it? When a group calls me over and they need my help and they're struggling with something, I try to encourage them, did you ask your partner first before you had me come over? And then I try to answer their question with a question instead of just giving them the answer.
Why do they look the same from the front and back? Do you look at it like that? Yeah, and like, why do they look like that? Why do they look the same? They're both 2x3.
They look the same from both sides, right?
Yeah.
I don't get number 2.
Why?
What?
2?
Yeah, number 2.
Well, like say I was like right here, and you were like right here. Why would it look the same, and why? Look at it like that, right there.
There's 3 blocks. There's 3. It looks like there's 3 blocks on this side, but on this side there is.
Yeah. They're the same. They're just backwards. Left and back are the same. Front and right are the same. Do we just like compare them and
Right. What do you notice? Do you notice any relationships between them?
yeah,
Okay, what little?
like that one shaped as an L, like that one shaped as an L.
Okay.
So like on this one's right, like it's just shaped as an L.
Except for what?
Oh, except
What's the difference?
this one has more cubes than that one.
Okay, they want you within a set. So this is a set and this is a different set. Okay, within this set, don't compare the 2 sets, but within the set, what relationships do you see?
Relationship.
Between,
They're all shaped the same,
Except-
except the other way,
what's another word
Like-
besides the other way?
like opposite.
Good.
Oh, okay.
Okay, and then is that true for this view, this set over here?
Yeah.
What about this one right here?
No. Because that one's straight. No, that one's straight and up.
Okay. So are those opposites?
Those opposites? Yeah, those are
Okay.
opposites.
And does it work for this one also?
No.
So they're not opposites on this first one?
Yeah, they're opposites.
Okay. Okay, so now you know what to do and how to answer this question.
Yeah.
Okay, you guys, we need to stop now and clean up. So we're going to have to continue this tomorrow. So what I need you to do is get all your materials back. Make sure each bag has about 15 blocks, no more than 16. Need all the markers. Keep all your papers. We'll discuss problem 1.1 tomorrow, and I will collect it.
Discuss Ms. Hardaway's questioning strategy. Why is the content of this activity important in the middle grades? How could you extend or enrich this activity?